Problem number 6 is a word problem where oil leaked from a tank at R of t liters per hour. The rate of the leak decreased as time passed, and you can see the chart there that shows you the rate values at different times. So right when the leak started, it was leaking at 8.7 liters per hour. That's how you want to read that table. 2 hours later, the leak had slowed down to 7.6 liters per hour. So what we were trying to find in this problem was we want to find how much oil leaked out. Now that's not easy to do from the information given, but what we can find is an absolute upper estimate and an absolute lower estimate. So this is a word problem version of a Riemann sum rectangles kind of question. So what you want to do is think of it like this. The upper estimate would be using the higher number between any one interval. So for example, in the interval from 0 to 2 hours, we know that at 0 was 8.7 and at 2 it was 7.6. So the upper estimate for how much leaked out would be, assuming let's say it was 8.7 that whole time and then it just dropped to 7.6 immediately. The lower estimate would be using the lower number for the whole interval. So again, the interval from 0 to 2, we have an 8.7 value and a 7.6 value. The lower estimate would just be using 7.6 for that whole interval. So if we want to try to kind of do this graphically, we essentially have points like this that are decreasing as time goes on. Since these points, the y values are rates, the amount of oil that leaked out would be the area under the curve. So our upper estimate would be forming a rectangle that used the higher value. Let me get another color here. The lower estimate would be the one that used the lower value for the entire rectangle. So I'll draw these all the way across. So those green rectangles represent the lower estimate of how much oil leaked out. These black values indicate the upper estimate. So how do we do that mathematically? Well, that's actually pretty simple. All these intervals are of width 2, right? Every gap here, this is 0, 2, 4, 6, 8, 10. So all these rectangles have width 2. So their area is 2 times the height, 2 times the height, 2 times the height, etc. So if you're adding them all up, we can just multiply 2. And instead of doing each height individually, we'll just add up all the heights in parentheses. And we're saying we're multiplying 2 times all these. So our upper estimate, we use the higher number for each interval. So we would use 8.7 for the first interval, 7.6, 6.8, 6.2, and 5.7. So this is adding up the areas of 5 rectangles where we use the higher number for each. The lower estimate, which I'll call L, we're doing the same thing, but we're using the lower number for each. So we're just not including the 8.7. 7.6, 6.8, 6.2, 5.7, and 5.3. So the concept here is really important because this is something that you'll use for many types of antiderivative and Riemann sum problems. So I'm going to use my calculator right now to figure these out. Oops, give me a second here. So I'm just adding these numbers up, multiplying by 2. So the upper estimate is just 70. So this would be, I guess the unit here would be liters, because this rate was in liters per hour. And our lower estimate is 63.2. So best case scenario, only 63.2 liters leaked out. Worst case scenario, 70 liters leaked out. Obviously, the reality is somewhere in between those two, because we don't know how this graph curved, right? If it was a curve that was closer to the green line most of the time, then it would probably be closer to 63.2. But it's possible that it was an overarching curve like that, and it was maybe closer to 70. So Riemann sums like this are just a way of estimating areas. And in word problems, you just have to consider that the area unit is always the product of the other two units. So one of them we had a rate, one of them we had a time. Rate times time gives us the actual amount, which is what we were looking for here for the upper and lower estimates.
The Teaching Center, UF's Learning Resource Center.